Hi there, my name is Bogdan, and in this video I'm going to go through the process of building a basic URL shortening application. I'm going to use Koyo, which is a web development toolkit built on top of Racket. And the purpose of the video is mostly to show you what the process for building something like this is. I'm not going to stop and explain everything, but if you do decide to use Koyo and you run into any issues or you have any questions, feel free to ask me either on the Racket Slack, on the mailing list, or just open an issue on GitHub. I'm always happy to help. So I'm going to get started. I'm going to create a new Koyo application. I'm going to call it Shorty, if only I could type, and then cd into it, and then take a look at the README. The README tells you what all the prerequisites are and how to set up your app for development the first time. Now I already have all these things. When you run Koyo new, it sets you up with a basic blueprint for an application that uses Postgres. So you need Postgres, and it also sets you up with a front-end build pipeline, and for that you need Node. MVM is actually optional, and then yeah, you can just follow these steps and get set up for local development. So I'll just do that. I need two databases. One is called Shorty and Shorty Tests. So just create db Shorty, and then create db Shorty Tests, and then log into that database. Whoops, I forgot to create user Shorty, and then log into that database, and then let's see, just grant all privileges on database Shorty to Shorty, and same thing for Shorty Tests. Take a look at the README again. So it tells me to build the front-end assets. I need to modify this command slightly just because I use a different version of NVM, but the one from the README will work for most people. All right, take a look at README again. Next, it tells me to install Chief, but I already have it. And then the next thing is to install the application as a Racket package. Shorty tests to bring in all the dependencies, and also just to compile it. So I installed both the web app and also its test package. Give that a second to run.
Finally, I need to copy this .env.default file to .env. So copy .env default to .env and take a look at it. All right, take a look at it. Okay, that looks good. And now I'm just going to run raco chief start. And what that does is it reads a file called procfile in my current project, and that proc file contains definitions for these two processes. One is the asset pipeline and how to run it. The other is the web server and how to run it. And so you can see it actually runs both processes in this one terminal session and multiplexes the output. So that way I need a single terminal to both build my front-end assets and also run my web server. And okay, so let's just look at what the structure of the project looks like a little bit. So we've already seen the README, the proc file. The proc file I'm not going to talk about. This is the asset pipeline that is used. Then package lock and package.json. These are both a part of that front-end asset pipeline. We've got our migrations folder, which has two migrations because the blueprint application actually comes with a basic user, registration login setup. Have our resources folder, which contains all of the raw front-end assets that get transformed and compiled down into the static directory, and this is actually what we serve as our static files. And then we have the two packages. One is the web app itself, and the other is just the tests. And so this has, because it's a Racket package, it has an info file with all the dependencies, the collection name, It has a config file that I'll talk about in a little bit, and it has the entry point, which is this dynamic module. What we have here is a system definition. So a system definition is comprised of a system ID and a set of packages, a set of components, excuse me. Every component has an ID, a list of dependencies, which are other IDs in this system. So for example, you see auth here, it refers to this auth component over here, which depends on sessions and users. And then the third part of a component definition is a function that takes all of these dependency components in as inputs and creates an instance of that component. So in this case, this lambda takes all of these arguments inside of this depths list and calls make app with them to create an instance of the application. You see here, auth is a little bit simpler. It just passes this make auth manager function, which takes a session object and a user's object and returns the authentication manager, and so on. We have a few of these. We have one for the database. I forgot to mention the dependency list is optional, and so because the database doesn't depend on anybody else, it only has an ID and a function for how to construct a database instance. And the nice thing about the system is because you have this, you have these well-defined links between components, is it lets you start and stop things in the right order every time. And so when this module gets run, you can see over here we have our main submodule. We call the start function, which returns a function that can stop whatever's been started. So we call start, get a function back, and then wait until a user, until we receive a break from the operating system. So that could be like a sigterm signal getting sent to the process, or the user hitting SIGINT, so like Control-C on the terminal. When that happens, we call that stop function. And the implementation of start is just calling system start on our prod system, so the system that we defined over here. And it returns a lambda that calls system stop on the system. And if I go back here to the logging, you can see that it starts the system and it starts everything in the right order. So the DB starts first because it doesn't have any dependencies. I believe the broker doesn't have any dependencies. Oh, the broker depends on the database, so it starts after it. The worker depends on the broker, and so on. And finally, the last thing to start up is the app, and then the server, because the server depends on the app. Okay? And if we look at what else we have in the application package, we have a components folder and a pages folder. Inside of the components folder, we have definitions for each of these components that are used in dynamic.racket. You see there are fewer modules than are used here because Koyo provides some of these for us, so we don't define them ourselves, like the database, flash messages, and so on. But the main entry point for the application itself is the app component, and what it does is it defines a struct that contains a web server dispatcher, and the make app function actually does the wiring up of routes to pages, and it takes in all of its dependencies, and those get passed into the individual pages that need them. It also defines a stack of middleware, and then builds the dispatcher and returns the app, the instance of the app struct that is eventually used to instantiate the server. So here we're taking the app, we're taking the dispatcher out of it, and we're passing it into the server. And another thing I haven't mentioned is the configuration module. And
the way the configuration module works is it uses a small DSL for defining configuration options, this define option thing. And the way this works is you give it a identifier, an optional default value, and an optional body to process that value. And what it does is when it gets loaded, actually we might be able to just see this here if I expand last expression. You can see that that expands to a definition where it tries to get that variable from the environment. So it translates the identifier to uppercase version, and then it prefixes it with the current option name prefix, which in this case would be shorty, like that. And so if there's an environment variable called shorty version, it'll use that. Otherwise, it'll use dev. And then optionally, we can modify the value of that version with a body if we want to. So in the case of debug, what it does is it checks to make sure that shorty underscore debug is equal to X. If it is, then debug will be true. If it isn't, then it'll be false. Okay, and you can do slightly more complicated things, but that is the basic idea. And so here we define an option for the version, debug, whether or not to turn profiling on, the log level, the host, the port, and so on, and the connection, the database connection parameters. All right. So let me go into my terminal, go back here. So my app is listening on localhost port 5100. If I go to localhost 5100, I get presented with a login screen and a trace of all of the instrumented functions that ran as part of this request. So I can see if my app is being slow. I can see exactly where most of the time is spent. So going from the top level, we see the request took 2 milliseconds to process. And then if I just go down here, I see that half of that time was just spent in the template. And then most of that was actually spent making preload headers, which is probably something I should optimize because that's unexpectedly large. All right, and so this is fully working. I can come in here, I can sign up for an account, I can go Bogdan at defen.io, make a password. It tells me I've signed up, but I need to confirm my email address. And by default, the mail adapter the default mail adapter that is used just prints every email to standard out. So I'll just grab this verification link over here, paste it in, and now I've verified my email address and I can log in. And all I see is hello world. All right, so let's try to make that a little bit more interesting. So as I said, the app component is actually the thing that defines all the routes, and every route points to a page. So that's what's in the pages directory. And so if I go to shorty/pages and look at the dashboard module, here's my hello world, and you can see how this maps here. So the root of the application requires the user role. I'm not going to talk about that very much, but essentially it just requires me to be logged in, which is why if I log out and try to go to the user page, you can see it redirects me over here and tells me that I need to log in. So log in, and now I can see the dashboard. And this route references the dashboard page, which is defined over here. And so if I modify this to say something like hello screencast world, and then you can see the web server automatically picks up my changes, recompiles the app and restarts it. So if I come back here,
It says hello screencast world, like you'd expect. Okay, so let's see. Next, I'm going to stop the web server and I'm going to run north to create a new migration. I'm going to call it add URLs table. It adds the migration in the migrations folder, so I can edit migrations, add URLs table. And let's see, let's edit the description. So this is going to be creates the URLs table. I'm going to replace that. Drop table URLs, whoops, drop. Every URL is going to have a serial ID, a serial primary key. It's going to have a code, which is going to be the short code. It's going to be not null and unique. It's going to have a URL that is going to be also text and not null. And it's going to belong to a user, so it's going to refer to a user ID, which is an integer. Not null references user's ID on delete. Let's cascade. It's going to have it created at, whoops, timestamp. And that's probably enough for now. And so when this migration runs, this table will be created. If we roll it back, then it'll be dropped. So that's the purpose of these up and down chunks. And every migration can contain multiple of these. So if I wanted to create 2 tables in one migration, I would create 2 of these sections. But this is all we need for right now. And over here on the left, I'm going to come in here and in the components folder, I'm going to make a new component called a URL, or maybe let's call it short URL.racket. That'll be less confusing. So lang racket base, and maybe let's also do the same thing over here. So instead of calling it URLs, let's call it short URLs. And short URLs. There we go. I'm going to require data. Data is a object mapper for Racket. So I'm going to use it to define a schema called short URL. The table is going to be short URLs. It's going to have an identifier, which is going to be an IDF, auto increment, primary key. I'm mostly going to repeat the information that's on the right. So string f, then the URL is also going to be a string. It's also going to have to be non-empty string. I need to bring in racket string. And then the user ID is going to be an integer f, and then created at is going to be a datetime tzf, and it is going to default to the current moment. So I'm going to bring in Gregor for that. Whoops, I have a typo. That's going to be wrapper, excuse me. Okay, and I'm going to provide my schema over here. And let's see. Now that I have this, I'm going to run my server again, get it started up, and it'll automatically run my new migration. Whoops. Looks like I have a mistake. Relation example does not exist. Let's see what I did wrong. Oops, migrations. URLs table example. Oh, that's odd. Oh, I accidentally edited the wrong migration. So let's drop table short URLs and then create the short URLs table, and then I'll undo things over here because we definitely want the users table. Yes, that's a lot better. And let me cause the web server to restart. And save this. There we go. It applied my new migration now. And okay, let's move on to adding a page to create a new short URL. So short URL.racket, racket base. I'm going to require Koyo Haml, and I'm also going to require the forms library and the template. And I'm going to call this, actually let me bring in Racket contract as well. And I'm going to call this create short URL page. It's going to take the database as a dependency, and it's going to return a function that takes a request and returns a response. So let's encode that in the contract. So it's going to take a database, and then a request, return a response. I'm going to make it void for right now. And I need web server HTTP. And I also need, let me do that, Koyo database. Okay. Yep, that loads now. And so I'll just return a blank page for now and provide my create short URL page. And also re-provide this new module that I added from the pages, from the all module in the pages folder. So what this module does is it literally just re-provides all of the exports from these other modules. And this is so that in the app module, I don't have to import, or I don't have to require every module individually. I just require this all module and then reference the pages from here. So let me add a new route for new short URLs. Maybe just call it short URLs new. It's going to require the user role, and it's going to use the create short URL page and pass in the database that it depends on. So remember, this syntax creates a function that returns another function. So it's a shorthand for create short URL page DB, lambda, request, and so on. Okay, and so here, what we get back when we make this call is actually a request handling function. Okay, I believe DB is actually database here, but I can, oh, actually we don't bring in the DB yet, so let's call it DB and modify our make app function to take a database. Okay, update our system definition here to specify that we want the database. And let's see if this loads. Yep, it does. So now I should be able to go back to my web browser and go to short URLs/new and see an empty page, which is exactly what I get. All right. And using this forms library that I brought in, I'm going to define a short URL form. What it's going to take is, let's see, what do we need? I guess we just need the URL. So it's going to have a URL field that we're going to ensure is a binding text and make it required. And let's make sure that it's shorter than 250, let's go 500 characters. Okay, and the end result of that form is going to be just the URL itself. All right, and then over here, I'm going to define a loop, and I'm going to use continuations to implement this form. So I'm going to bring in Koyo continuation, and I'm going to call send suspend dispatch protect. That takes a lambda, and that lambda needs to take a single parameter, a single argument called embed URL. And we're going to match on form run, which takes the form and the current request. And we have two options we care about. If it's passed, we get a URL back and ignore the third value. And we'll just return a blank page for now. If it failed, and we ignore the second value and we use the third value, which is our widget renderer. So I'll just build up a page over here. Let's see. Let's use some HAML container. We're going to have a form whose action is going to be the embed URL of our loop. It's going to have a method that's post. And let's see, what are we going to have in the form? We're going to have a button, a submit button. Type is submit. Whoops, that needs to be lowercase. Create short URL. And we are going to have a label. And that label, we're just going to have the string URL. And then that's going to wrap our widget, which we just called URL, and the HTML representation of that widget is going to be a text field. Yeah, that should be enough. I'm also going to render a widget for the URL's errors, so widget errors. And that also should work. Let me just bring in the match library. All right, so far so good. And if I go back over here, we have a little form. Let me also add an H1 header. So create a short URL. Go back over here, wait for it to restart. There we go. Now if I try to submit the form, you can see I get some validation. I would also get a different message if I were to paste in a URL that's longer than 500 characters. But yeah, okay. So now, for now, I'm just going to display the URL to standard output. So display it and then flush. And come back here and execute. So let's make the URL to racketlang.org. See, so there was no output because we ended up on this branch. We displayed the URL to standard output. Here it is. And then we rendered an empty page. So instead, what we should do is I'm going to go back to my short URL component. I'm going to create a function called create short URL. It's going to take a URL and a database. Let's actually give it a contract. So it's going to take a database and it's going to produce a URL. And I'm also going to need to bring in Koyo database and use its with database connection macro. It's going to take a connection out of the database connection pool. So this is going to be bound within the scope of this S expression to a database connection. So I'm just going to call insert one on and make a new short URL. And in addition to that, we're going to need a user ID. So I'm just going to require that that be passed in as an argument as well. So user ID, and let's provide create short URL. Whoops, I made a mistake here. This should be called short-URL. Load the module. Looks like it broke its own contract. Oh, because it takes a URL as well as argument. Okay. So now if I go back to my page, I can define the URL and call create short URL, pass in my database reference, and pass in the URL, and let's see, where was that? Components, auth. Yes. So the auth component exposes a parameter called current user, which I'm going to use to grab the user ID. So it's going to be user. Actually, let me do this way. Current user. And I'm guaranteed to have a user here because I've set the role for this route to require a user. All right, and I'm just going to redirect to dashboard page at the end of this. And I need to bring in a couple more dependencies. So I need to reference the short URL component, and also I need to reference components user.racket to get the user ID function. All right, so now if I go back here, let's see, what was it? So short URL is new, and I try to create a URL to Racket Lang. Oh, looks like it failed. Oh, that's right, because I need to generate short URL code, because the code is also required. So let's see, how are we going to do this? For now, I think what I'm going to do is just use let's see, Racket, crypto random bytes probably, yes. So how long should we make this thing? We'll just get 8 random bytes. So define, generate code, and we'll do crypto random bytes. We'll get 8 bytes, and we'll just convert them to hex. I'm actually going to use a for string here. B. Number to string B16. Now that's not going to be perfect. Oops, where is for string? For string comes from, oh, it's in the teach pack. Okay, I'm not going to use that then. I'm just going to call with output string and then for every byte I am just going to display converted value to the output. Let's see if that works. Call with output string. We probably need Racket port for that. And then for crypto, random bytes. I wonder if, nope, that looks good. What module is this in? It's probably in Racket random. Yep. So when I generate a code here, that looks good, but then I need to add some padding if this isn't at least 2 characters long. So the width is going to be 2 and the left pad string is going to be 0. That, whoops. And maybe instead of call with output string, I'll just do with output to string. Just so I don't have to write out that out parameter, and now I need Racket format. Alright. Whoops. Made a typo, it should be width. Great. Alright, let me just do a string length of that. Okay. I'm convinced that that works. By my very extensive testing there. Code, so we'll generate a code over here. And yeah, that should work. Why is it complaining about Gregor here? Ah, my sorting was off. Okay. Going back here. And I type in racketlang.org. Oop. Cannot convert the value t respect to the string. Huh. I wonder what it's complaining about there. Let me just pull this up here. The URL is going to be that. And the URL, and let's just display the URL. All right. So for the URL argument, I'm doing something weird here. Let me see. So page, short URL. Oh. I made a mistake. It shouldn't have been wrapper, but contract. So what was happening here was we were passing a string
to as the URL field on the schema, and then it was being processed by this function, and this function returns true when its argument is a string. And so that's how we ended up with a Boolean value instead of a string in this field. So this should actually be contract. And then for the wrapper, what we want is string trim. So we want to remove any spaces from this URL. Okay, I think I can drop these and also just inline this over here. All right. Going back here. Okay, now it's complaining that the dashboard page does not exist. Let's see, so components, app. I wonder if I made a typo. Dashboard page. Pages, short URL. The mistake was that this should be a string rather than a symbol. So let me go over here and create another one. Oh, I'm sorry. It was actually so what I wanted to do was create a URI to the dashboard page route, but I called redirect to with this identifier, which obviously doesn't work because redirect to expects a URL. So what I needed to do was call reverse URI, which I'll get from Koyo URL. And the way this works is this is a special version of dispatch rules that works mostly like the dispatch rules in the web server, except the mappings for reverse URLs that it creates are based on the identity or the name of the function that is passed in for the route. And so if I want to create a reverse URL to the dashboard page, this is what I have to do. I call reverse URI and pass it the symbol dashboard page. If I wanted to create a reverse URL to the create short URL page, I would do the same thing, just replace this with create short URL page and so on. Same thing for login, logout, and yeah, you get the idea. So going back here, give it a second to restart. Okay. Create the URL, and it takes me to the dashboard page. But instead, I should probably define let's see, short URLs page that also takes the data in the database component, and then takes a request, returns a response, and the page is just going to contain, let's see, your short URLs, and it's going to contain a list of every short URLs that belongs to the current user. So user ID, current user, and actually maybe let's make this a table. It's not going to be pretty, but that's not the point here. So I'm going to have a table with a T head, table row, and the TH is going to be the code.
and destination, and maybe another one just for the full link. Okay, and then tbody, and then for every short URL, we're going to have a row. That's a TD, and we're going to show the short URL code. We're going to show short URL for the destination, and then just show the empty string for now for the link. So going back to the short URL component, I'm going to add a new method. List short URLs, takes in a database and a user ID, and returns a list of short URL values. So I'm going to call list database connection again, bind connection to a connection from the database pool, and I am going to look up, or rather I'm going to do a for list using in entities with the connection and perform a query here from short URL as SU, where the short URL's user ID is equal to the user ID that gets passed in, and I'm just going to return each individual short URL, and maybe I'm going to order by when the short URL was created at descending. Okay, and for the little tilde greater than threading operator, I'm going to need the threading library. Okay, and then also provide list short URLs, and now this module should compile. Oh, it's complaining at line 35. I don't need the unquotes. Okay, that seems to work. Let's provide short URLs page, and then in the app component, let's hook it up. Short URLs requires a user list, or I just called it short URLs page, and it needs the database. And that seems to work. So if I go to the short URLs page now, you can see I have each of my short URLs. It seems I have a mistake in my code generation. If I go to short URL, I probably did the tilde-a thing wrong. Let's see, I probably need to tell it that it needs to align to the right. Yes. And so let's just try something real quick. Say this 5. I want it to be right aligned left pad string. Whoops. And the width is going to be 2. Okay. And just to be sure, if I drop the alignment, then what happens is it just uses space. Yeah, it adds a space after the 5. All right. So now let's just go to the new page again, create the short URL again, and let's change that page so that instead of redirecting to the dashboard page, now that we've added a route, components app, now that we've added a route for this short URLs page, I can just reverse URI to it. So a short URLs page. Give it a second to restart, and go to short URLs new, create a new one, and yeah, it got redirected here. Cool. So let's produce these links. Back in the component short URL component, I'm going to go ahead and add a new function, contract short URL link. It takes the short URL and produces a string. And let's just see what that's going to be. Void for now. We're going to use a function from Koyo /URL called make application URL. So we're going to make an application URL, and this takes a variable number of path elements for the URL. So in this case, that's just going to be short URL code u, and we need to bring in Koyo /URL, and we're going to provide short URL link over here, and back on the page we're just going to use it. All right, seems to work. There we go. Let's linkify it. So this is going to be an anchor. href is the link, but also its content is the link. Refresh. There we go. Now if I visit any of these, it just tells me the page wasn't found. And also those URLs aren't that short, so let's use fewer bytes to make them. All right, let's see. And yeah, so next let's let's add a page for when you visit a short URL, or maybe let's call it redirect short URL page, or maybe it would be better to call it short URL redirect page. It takes the database, it takes a request, and it takes a code. Database returns a function that takes a request and a code and returns a response. And what we are going to do is just look up the URL. So just call lookup short URL, pass in the database and the code. Unless the URL exists, we're going to move on to the next dispatcher, which eventually will just show the not found page we saw earlier. If it is found, then we are just going to redirect to the short URL. I really should have called that the destination, but whatever. All right, let's define the lookup short URL function over here. db code database string, and then it's going to be an optional short URL. Okay, so with database connection, we're just going to look up using the connection from short URL as u, or as su, where the short URL code is equal to the code. That should do it. So just look up short URL, short URL redirect page, hook it up. Oh, we need to bring in the next dispatcher as well, and also let me fix the ordering of these imports over here. So the next dispatcher, I think that comes from web server dispatch. Well, I don't remember. Let's look it up next. Dispatcher. Yeah, it's dispatcher's dispatch. Okay, that works. Great. Come back here, and I forgot to hook up this new page. So in components app, whenever we get a string argument, we don't need to set the role because anybody should be able to visit these URLs. We are going to map that to the short URL redirect page, pass in the database, and then the routing system takes care of passing the string argument as the code argument over here. Okay. Why is it complaining? It's not. Okay. Oh, of course, this needs to be the last thing now because routes are matched in order. And so what's happening is when this request comes in, it's checking each route in order, but because it gets here, it just treats the short URL path as an argument and tries to actually run this page. So let's make this the very last thing over here. I probably made a mistake there. Yep, there we go. So now I still have my list of short URLs. I have my login page, my logout page, and all that stuff. Go back to my list of short URLs and hit one of these links, and it takes me to racketlang.org. So yeah, let's do one more thing. I'm going to go to create a new URL here. And okay, now we have these shorter codes. I'm actually going to go ahead and make those even shorter because I want to show a problem that we have. Short URL, and then rather than using 4 bytes, I'm going to use 3 bytes. Maybe even 2. Okay. And I'm going to come in here and stop the server. And I'm going to use this Racket Koyo console command, which this sets up a REPL that also starts the system in the background. And it binds every component. So if we look at the system definition, it binds each one of these IDs to an identifier that's like $%, and then the component ID. So if I want to access the database, I can just do that. And so what I can do now is I can require shorty/components/short_url.racket. And if I just want to list all the short URLs, I can just pass in my database and my user ID. And you see I get back a list. And I want to show a problem that probably many of you have noticed, which is I'm not dealing with what happens when there's a code conflict at all. When I created the migration, let's see, where is it? So add URLs table. When I created the migration, I said that it had to be unique. So what's going to happen if 2 of these codes clash is the database is going to throw an exception, which is going to propagate all the way through to the user. So if I just do this a bunch of times in range, let's see, what's that? 2 to the 16th. So if I just try to generate, what did I call it? Components and, whoops, components. My Emacs is failing me a little bit. So whoops. Short URL. So if I call create short URL repeatedly, pass in the database, my user ID, and racketlang.org URL, you can see the error that we get. So when there's a clash, when there's a code clash, we immediately get one of these constraint errors. Right now, just because I'm going to be lazy about it, what I'm going to do is just catch with handlers. I'm going to catch that particular error. Doesn't fail. Let's see, what kind of exception is it? fail. Yeah, so there's a fail SQL. And then when we get that particular let's see. So it produces, if we want to extract the info, we have to do that, but we all we really need is the SQL state. So I'm going to do a case on some fail SQL state of the exception. And when the state is a string, that, I'm just going to do a loop. Otherwise, we re-raise the exception, then like the loop over here. Okay, let me bring in that exception from the database library. And now if I quit the console, open it back up, and then require my stuff, and then run the for loop again, you can see it keeps running, it never fails. I'm just going to cancel it so it doesn't create a ton of entries. Let's see what the length of my short URLs is now, because I let that run for a while. Whoops, let me run the server, Racket Chief start. Yeah, there we go. We got a bunch of them now. But yeah, each of these works. Come back here. And clearly this takes a long time, a relatively long time to load. We can see here where all the time gets spent. So as I mentioned at the start, this is actually an instrumenting profiler, I mean. And so we're not seeing, like we are seeing the database lookup for the user because that's instrumented. But we are not seeing, oh, I guess the call with database connection is also instrumented. So we are seeing the call where we get all of the short URLs, and that takes up most of the time. So just getting all these 3,000-ish entries from the database is where we spend most of the time. But just to be sure, let's add a with timing. Is it with timing? With timing, yes. Wrap the contents of our list short URLs function with the with timing in a with timing block. So it's going to be short URL, and the function name is list URLs ... Okay, and bring in Koyo profiler for that. Let's see if this compiles. It does. So now if I refresh the page, you can see I have my timing for the short URL shows up, and I was right. So this database call maps to the one inside of the list short URLs function. So yeah, I hope that made some sense. I hope it was interesting. And if you want to learn more, head on to koyoweb.org or to github.com/bognp/koyo. And as I said at the beginning, I'm usually available on the Racket Slack and on the mailing list. So if you have any questions, feel free to reach out to me. Thanks.